going to make an unstable isotope. We're going to make an unstable isotope. Any unstable isotope. So how do you know it's unstable? Any unstable isotope.
Actually, that looks like actual language.
Sorry. Okay, we're good? Now we're going to get a little more exotic. Now I want a isotope that undergoes neutron decay. An isotope that undergoes neutron decay. Tim, you want to put my picture back up on the board so it's colored? Tim, you want to put the color one up on the board? Yeah, that'd be good. Put the color image back up on the. Yes. I don't want to put down the color. No, well, either way. Good job! So you can't make that one on this particular card. Okay? Right. Okay? Okay. Yeah, I told you to get a little tricky.
Is the proton decay a triangle or a
Star.
star? Where's the star?
The yellow triangle is something that undergoes proton decay. So make an isotope that undergoes proton decay. Proton decay. Go back to the picture. So proton decay is what?
A yellow triangle.
Yes. This is what all the clues you can put them on an index card, and one student can say, okay, now let's go with neutrons, there's more protons than. Well, it's more, but the card, the bingo card, for every student, and one who's actually the spokesperson who hand out the clues. Pretty much. I mean, this is how we play.
All right. Any questions?
No.
Back in teacher mode now. No, go ahead. Go ahead.
Just for little, like, I have freshmen who don't even understand, like, neutrons and protons.
You know,
This is such an easy, fun way to do that.
you know, it
You
gives
don't even
you
have to talk about decay, right?
right, and but it leads into it.
Yeah.
Okay, I mean,
Yeah, love it.
and that's where this next second game kind of the nucleosynthesis game, where you go into the mechanism of decay, which I wouldn't even mention that here. We just said, find something that undergoes proton decay. Okay, now next, what does proton decay mean? What does alpha or beta decay mean? All right, so and you can make up your own clues. So I mean, you can make up your clues in as detailed as you want, depending on what you're going. But I could give a clue and say, okay, make an isotope that's left after carbon 14 undergoes beta minus decay. All right? And, make them think a little bit, again, depending on your level, if they come up with nitrogen 14, okay? If they understand that mechanism, that could be something you can lead into. So making up the clues is kind of up to you. Getting them to actually physically make it is the thing that we both kind of fell in love with when we saw this, as opposed to just abstract
You have
pictures.
clues on the website. There are clues on the website.
Some.
Yeah.
There are some hints, but I would say probably the pinnacle of understanding might be to have the students make them as make them clue, because it's sort of like a Jeopardy type of thing. You look backwards, and I think that helps them too. What's doable based on all the nuclear rules versus just make up stuff. Well, if it's not possible, I mean, it's easy to say it, but if there's no physics background in it, then
Okay,
Yeah,
any
it
other,
works both ways.
any other questions, comments? Okay? Pretty neat, okay? And I've actually used this to teach elementary school teachers, okay? On some certain level stuff. All right, so that's isotope bingo, and yeah, we could go a little bit further.
Some schools have this laminating type of thing. So once you cut them, you put them and you have them forever. With this, forever.
Or put them in a sheet protector or something like that.
Keep doing and have them permanently.
The cards are available online or you do?
Well, the cards, they have some for the isotope bingo. I mean, this type of cards. I'm not sure how many they have or how many types.
I don't remember.
Well, yeah, there is some samples for it.
Yeah, and it's easy to make up. Actually, you can cut right off the chart of nuclides.
I was about to say that too. Once you get the chart, it's either
You
or
actually cut sections, so if you want to use more marbles and put it.
take a picture,
Bigger isotopes.
put it on take a picture of it, and then you cut it. And it's really based on what section. I mean, the chart that you get, this is obviously up to the 8, but I mean, it goes to what 76 all the way up. So cut an 8 by 8, pretty much anywhere you want within the. And they said I mean, we pay for it. Obviously, it's a government taxpayers sponsor. So for the school, they send the chart. Okay. Let's go a little bit to the next one. We need dice.
Dice.
We need dice for every group.
Okay, you can give me that. Yeah, Timmy and I have been doing this for a long time. We have a great partnership. He does all the work, I get all the credit. Okay?
No, we all just gonna give two dice. And there's little rules for this.
Now, what else would get kids more excited about playing with magnets, marbles, and dice? Okay, in class. It's good when if you use it, the kids come back after school because they want to keep playing. Okay, and it's something that
So, pair of students. It's good to have pair of students just because they can talk to each other instead of having one versus the other. So 2 versus another 2. And you start with the hydrogen nucleus. So you have the magnet and one green ball. No, the proton is green, right? Okay, so then the other one. Which one is? Forgot the color code.
you got the proton.
Proton is yellow. Okay. So you start with the proton, and then you roll the dice. Let's see what you get. The die roll.
All right, first you have to start with.
And that's the rule. Yeah, that's what you start with the proton. The hydrogen nucleus.
Okay, so all you need is,
One yellow in the magnet.
all right? All right, so you want to separate all your other stuff. And this is what you're starting with. Okay?
You roll the dice and you add them up. Right? You add whatever they said. So we got here 8.
And the first team to get to oxygen wins. Okay? Alright? So you roll the dice, and the dice tells you from the little rules over here what there is due to your nucleus.
What is the move? The dice tells you what's the move.
Is this the total?
The total. The total.
So if it is radioactive
So you guys, if you got 8,
Now,
you have a radioactive decay. If you get 1-1, you are bombarded. And this is the bombardment is kind of fun because you have the other team try to get a proton and try to show it and see what happens. Sometimes if you throw it weak, you get stuck to it. So you're actually helping the other team in order to reach the oxygen faster. Sometimes you smash it and you break it apart. So they have to go back. Yeah, let's say we're kidding. I mean, it kind of have to be a little controlled, but it gets a little out of the way. bombarded is you take a proton, you take a neutron, and from the other team, you roll it in. Now, this is where you can roll it slow, where it gets attached to it, but in this way you are helping him in order to reach the oxygen. If you try to get it on harder, maybe you can take another proton and he goes back to with less number of protons.
You can do it with someone else.
Well,
You should be playing against
Oh,
someone.
I didn't realize that.
so I can, you know, if you roll is roll, okay, well, I help you, I take this bombardment. because
So yeah, so this game is designed to play against another team.
Right, so I give you another one.
So you roll once, they roll once, you roll once, they roll once.
Come with this draw. And if somehow gets this, that's what it's about. You throw it at that one step.
Set up, you don't have to do it. I roll, and I do that, and you roll just them on.
Yes.
Ah.
Yes, that's what the team versus the
No, it doesn't have to. Could be any extra clock.
You don't want to reach
You would have two kids playing the team. So you would have 4 teams or 2 groups of kids playing against each other.
I would start with
You take away yeah, well, it's either beta minus or beta plus, so you have to take away what physically makes sense. There's no decay to take the neutron out, so it doesn't. So you have to take it out, the move that's physically possible.
Now you will. You guys anything you want.
Now, one thing you mentioned that the moves that you do, they have to be physically make sense. I mean, you can do beta decay, you can do a collision with alpha particle, not just to take a neutron out of it because you feel like it.
So when you collide, are you supposed to,
That's
Why do
capture.
that? I guess I think
so if you have that collision with another person, you actually, what will happen? Are you really colliding them together or
You
no?
collide it, yeah.
And then when you pull it apart,
When you put apart, that's a decay. You can move it. Well, you have to.
kids, they collide together.
That's an alpha particle. Okay, that's what happens. So you got stuck with this, and the other one is waiting for the next move. Field infusion, alpha particle, right? When you get 9 to 10,
Yeah, Gordon Shore explained it, you know, it's explained in the handout.
7 decay.
if you end up, well, it's just probably, it is, so maybe it happens, has a very short lifetime, and let's see for the next move, or, I mean, this stuff makes it in my
Okay, which leads to a very, very, very important question. If yellow marbles are protons and green marbles are neutrons, then what's this?
two quarks.
So, what is it? I don't know, I just invented this a couple of months ago. I just found these over the summer, okay? And I said, I gotta get a few of these because, you know, I guess it's in the middle of some kind of beta decay, either one, I guess. It's either gonna, you know, proton's gonna turn into a neutron, or neutron's gonna turn into a proton. So it's in that metastable transition state that, it's eventually turn over green or turn over yellow. It does that every day. So, just adding to it. Oh, it's a neodymium magnet.
It's pretty strong, right?
Do they sell these things or you buy them?
They come as a,
Yeah, if you want to, it's a neodymium you can get anywhere. What's that guy, Mr. Magnet, Mr. Magnet Source? I forgot the other name.
when you order, I mean, this is what's.
Yeah, we don't make any money on this. This is
I mean, we just advertised for it, but there are two different places now where Zach mentioned that it's through him or directly to the Gina website. There should be info over there, but when you order, this is what's,
They're $10 a pair,
I was about to say, yeah,
something like that.
I mean, the pair
And that
is a,
includes 2 carbon 12s plus a,
and they give you one electronic proton.
yeah, which is when you, yeah, we haven't talked about those yet. The green and the blue and the,
620, I think this is about, what, $200-ish?
no, less than that.
Less?
Whatever. Yeah. You know, you can dig them up on your own.
Where,
You probably want to have that, let's see, 6 pairs, I would say.
okay,
$100.
let's go to the next one. The next game, it was part of something that they had built. They call like a nuclear accelerator, but this is what really got Joe and I fascinated about it. Said, well, we have to come and make one on our own after we got back from the program. But theirs, based on probably they have more money and good budget, they make it pretty expensive. So we went to our nuclear science store,
Nuclear
Home
supply
Depot.
store, Home Depot.
We went to Walmart. We had a workshop at my school back in, I think it was last year in September, to make and take. And
We built about a dozen of these.
this is how it looks like. It's a little bit an improved. This is just added separately. I would say more like a carriage type of thing, and actually to make it more better. Let's put it this way. I'm missing a Velcro piece here that I'm just gonna tie it up, and I attach this and actually go from
Portable particle accelerator.
Yes.
Okay? It's
One of the worksheet, it sort of gives some instructions of how to do it, but just by picturing a little bit, it's a support. We have here this pipe. I mean, there's nothing. It's glue or attached to each other. The pipe for something that we call a low energy. If you want a little bit higher energy, and we drop the marble from there. And if we really want to get fancy, get even higher energy, it goes up to there. Now they have to collide with something, right? Let me put this down.
So your curtain rod is just to carry the extra.
Yes, yes, and to be strong enough for it. Now they have to collide in what they call a fragmentation box, where they split. And this is just a Walmart box with a hole attached to it, and this is the.
You had to see the
This is
two
like
of
a
us at
portable
Home
circuit.
Depot, figuring out how we were going to turn that other thing that was made out of this big steel thing, and it cost them about $400 to make, which was the original one that they made. And we were able to streamline it and bend it down, get it down to about $40 a pop. It was fun.
So we need the target, the fixed target, and that's where the proton gets accelerated, is going to collide with the target. And just construction-wise, the drill to make a hole slightly bigger than 2-inch pipe. Here in the cover, cut X and Y. So we got this from, we use for gutters in order to avoid the leaves, and just cut a little piece of it. One nail with a large head. If you go it through, it's not gonna, the magnet is strong enough in order to hold it. So that's the target. We
So
put
we
it
have
onto
it's not like the LHC, it's not a collider, where both things are moving. Well, maybe we'll get to that later. But this is a fixed target collider experiment, so.
Right.
So
So
there's
it's
our
stay-
fixed target.
You stay like this, and you do have a little bit of flexibility to move it closer or further away, or if you put it on the y-axis, let's call it this way, a little bit left to right. So can get the glancing or a head-on collision this way. Actually, it's here. I put it intentionally a little bit offset. Right. Probably it's good to check to see if level-wise on vertical. This is like a U type of shaped nail that
What's your target?
that will
Did
do
you
it.
make
It's
that?
carbon 12.
Yeah, you want to use that or you want to use beryllium 9?
We should do beryllium 9 is the more typical.
Yeah, it just kind of looks a little better. I would-
Now, there is actually, we should go to, this is how probably it's gonna look like in terms of what you're gonna see. It doesn't have much. A snapshot of when the particle is coming, that's the target, whatever happens, and what is left over.
Yeah, depending on what you decide to be your bullet. So you can shoot a proton or a neutron at it, you can shoot an alpha particle at it, you can collide two carbon-12 atoms and see what happens. You can do something with it.
We have 9.
You can make it a relativistic heavy ion collider and crash a big particle collider if you really wanted to. But
What do we have for beryllium? We have 4
4 and
and
5.
4 and 5.
Actually. 1, 2, 3, 4, 5.
beryllium 9 works nice at the target because it leaves you enough surface of the magnet where you can capture it pretty well. If you use a carbon-12, it can still happen, but it's, you know, I mean, it's a model, it's not perfect, all right? And
Well, speaking of that, this is something that we have to be aware of when you collide. Some weird things might happen, which in reality, I mean, based on the conservation of number of protons, this might not gonna make sense. But it's also probably good to engage in a discussion that will, just say this.
if you get two protons sticking together to make helium-2, which I don't think that exists, right? There's not only there.
Probably not.
Or
We can look.
lithium-3 or something.
It's a good way actually having that nucleus chart, if whatever happens, does it exist? And the idea is
Or has it
maybe,
been,
or has not been,
has it
yes.
been made yet? Has it been seen yet?
Probably the chart look like this and you get an element that is completely off. Which is, or maybe has a very short lifetime, you know, 10 to the minus 12 seconds or whatever that might be. So now we can get a neutron, get a proton,
Whatever you want.
just one, low energy.
Oh,
Sometimes, if we really do it very low, let's try it. Get a little closer
It
maybe.
does take a little tweaking. And of course, so we just set it up.
We might get captured.
But that, I mean, makes a great point. You're not, you know, neutron capture or proton capture doesn't happen all the time. Things just get scattered off. And,
Oh, that was so close.
That was close. It depends on how you face the magnet too.
yeah, you want to,
Probably is.
you gotta tweak it a little bit and get a little
You can
magnet
move a little bit.
surface exposed where you're going. Ooh.
So eventually, that's a good try. So statistically, it's possible.
Yeah, but it's it's not something that's gonna happen every, you know, the randomness of nuclear stuff is
It's
just a,
part of the, right. Then, what else? We can do the
ooh, alpha.
helium.
Yeah.
The helium one.
I like alpha bullets, yeah.
Now, the alpha bullets, we can do it like this or without the magnet.
No, I think you need the magnet.
Or just put it together. Right. This is the reason actually for the alpha particle, I think is the highest thing, that the 2-inch pipe and even 1.5 kind of works well. Go. Ooh, lower energy. We need probably a little bigger.
Yeah, now the fragmentation box that they had at Michigan State was really nice, looked like a Lexan box. It cost about $100 and it was really, you know, ours cost about.
This one was also with plexi and
So I mean, you know, you want to dress it up and make it a little nicer, that's something you can certainly do.
So something happened, and then again, count the number of protons, count the number of neutrons, try to come up with a nuclear equation, conservation, and see if it makes sense.
Do we make a real isotope? Is it, possible for this to take place? And what is it? Right, now,
We have, probably we can go to that too.
of course, we're nuts, so we took this one step further.
And they said, well, it's good to have a one fixed target, and
Which is certainly one type of experiment, SLAC, which it's not
Accelerate.
working anymore now at Stanford, the Stanford Linear Accelerator. That's kind of the way it works, okay? It's a fixed target experiment, but now if we go to something like Fermilab or the LHC, right, at CERN, it's a collider where both things that are colliding are being accelerated towards each other. So, my maniac partner here.
we made
This,
two.
This is proton neutron, what is it?
That is the carrier of the strong force. That's the glue on that you can't see. It's the carrier of the strong force that keeps the nucleus back together. So it's not a particle.
I know.
It's,
These are the particles, but
Right.
what about this? How you will define this one?
it's part of the model. It's the force that holds the nucleus together. You know. Usually it's, again, it's only a model. It's, if you talk about the strong force, that's the carrier of the strong force. It's the silver glue on.
So for this, we accelerate two. What can we
Need a volunteer?
pick? I was thinking, one thing that works good here is based on to be conscious about the reaction time. It's good that one person kind of dropped them at the same time instead. Otherwise, there's going to be a slight delay and one gets after the other. But what can we do? We can do 2 carbon to start with.
You're going to combine two carbons together? You are a maniac.
4, 5, let's say 6 of these. 2, 4, 5, 6 of the other one. Actually, I think we should take it with another particle. Now I realize something. I made one for David, and this is an inch and a half, and this is 2. The 2 pipe, the carbon fits nicely to it. This one, it doesn't. So let me get a little bit less particles on it. I think this will go. Okay. So we have a carbon,
Carbon 12 with
12, and
alpha particle. There you go.
if we make it alpha, I'll take one out.
There you go.
Okay, and an alpha particle. So we can write the nuclear reaction carbon plus the particle and see what we got. We got 2 free protons, 1 neutron, and whatever it's combined here.
What is it?
4, 5. We have 5 neutrons, no 6 neutrons, and 1, 2, 3, 4, 5 protons. So that's 11. 4. We can look on the nuclei if there is such a
Should be.
isotope for it.
And what's the state?
And what's the B? 4 on 11. You have 5 and 6. And apparently it's the most abundant one. It's 80% abundant based on the nuclei chart. And then really give the freedom of just pick any sort of elements and just collide them and see how the nuclear reaction works. And then the chart allows you to look at the visibility of it.
Okay, so anybody want to try?
Yeah, this is what. I posted some instructions on YouTube. If you ever want, Saturday to list the material. Actually, there are 2 parts. It took me so many takes how to do it. And I had my daughter holding the camera and other things. But if you go on YouTube, look for fragmentation box
I'm gonna collect
instruction,
the
you'll
marbles.
see two videos of how to do it.
Do you have your email address in this packet?
No, but I'll give it to you. is strictly from the PEN program.
Okay,
I'll go crazy.
thank you so much. If you run another,
Yeah, I got it, I just was trying to save it.
make it on this,
Yeah.
I'd like to.
We had one in September, we had, about 6 people. 6, yeah, and they came and Joe and I will make it in my room. Very simple material, we just need to have some tools, screwdriver, a drill. We pre-cut this by a teacher from a workshop, help me out to pre-cut it.
Excuse me, I'll be hosting technique, so if we invite you to come and do this technique with you.
Okay, yeah, I'll make it
I'll
happen.
contact you.
We'll get, yeah.
Bring that one. I'm gonna wait till you go around the whole road.
I will say, the others probably say try to squeeze everything in, no more than a week. Each game with the kids, they get bored much faster than you do. Once they know a little bit of a background, 1 day for bingo, I think it will say, a simple double period, 1 day for trivia synthesis. I use this for projectile motion too. Come on. Marble, put a photo gate here, we calculate the speed that is coming out, where it is. I mean, just as an additional type of thing. Yes, let's even try to, this is pretty much the bulk of our, I would say, the presentation. The rest of the time, it's really probably
You guys want to play around a little
get
bit?
the hand on the marble, try to see how they work. We can look at one.
Yeah, we'll talk about it. Okay. We can talk. Okay. We'll talk. Yeah, right now my calendar's pretty busy.
The program is well worth it to
Yeah,
go in
March,
the summer.
I'll talk with the council members and I'll go it down with it.
Yes, it's a good, and I think for New Jersey was the only us where they went last time.
Yes.
It's a week spent there.
Yeah, all you have to do is pay for your transportation to get there. Once you get there, the meals and the rooms and everything is.
Yes, yeah, I really think it's good. And the coolest part besides we learned this, they really get you into the lab where they work. They spend their day by day and they show you all kind of the Mona detector, and they put the radioactive materials to real to try to in front and what you get, how to interpret the data, computerized, they have graduate students. It was a nice program.
Thank you.
Okay, so, any other questions? No, I don't, but if you have a flash drive, you can give everything electronically.
I'll give it electronic copies.
And it's all available on the website? It's all available on the website. All I do is want your email address and let you download it. There's actually on the website, there's actually plans to build those that they copy from us.
I know, I was just gonna say, I knew you remember.
A couple other questions before you guys fly and take off, which you can do if you thought this was okay and you want to keep up and stuff. I don't know how many of you are members of New Jersey APT. If you're not teaching physics, we're actually expanding and doing a lot of workshops in other areas, in middle school areas and physical science areas. If you want to just check it out and be put on our listserv. We have a listserv of sharing all kinds of physical science type information. What you need to do is email me, and I can add you to our listserv if you're not a member. If you are a member, you're already on, I'm sure. If you're not, if you just email me at Spacshelby, S-P-A-C-S-H-E-L-B-Y, S-P-A-C-S-H-E-L-B-Y, and just tell me you want to be added to the New Jersey APT listserv. Spacshelby at yahoo.com. Okay?
Thank you very much.
And you want to be added to the listserv. And tell me what form you want. You can either get every email that goes out, which is not a lot, maybe 3 or 4 a day, or you could get digest version, which you get one each day. A summary of the
I
day.
saw with guided lessons right on that.
You know, and we don't have a ton of traffic on ours, you know, sometimes it's good stuff, you want to get, you know, something might be happening today, hey, did you hear what happened today, that just, you know, the sun blew up or something like that, you know, so it's like, there might be some interesting news, but, yeah, if you want to get involved with that, it's free, it doesn't cost you anything, and you can keep up what's going on. Just contact me.
Thank you very much.
Want to make a collision, go ahead, be my guest.
I like take that.
That'd be good.
No problem.
Don't need a folder, just throw it on, that's fine.
I put them all based on the.
Gotta take some time and make up some more bingo cards, maybe. Different ones.
I just laminated the one that I have, it's only one that I have. But from the look guys, I think this probably might be good. Take a picture, take it to Costco or CVS or somewhere, and they give you exactly nice on a photo paper.
But can we print out that nuclei chart? That's the thing I want,
There
On
are
that
online
website.
versions of it,
the online versions.
and then there's print versions.
Right.
Did Brookhaven, they'll send it to you for nothing? I didn't realize that.
I think they do, yeah.
Yeah.
Say if it's for school or.
Okay. Because I have a couple, I have an old one that I have. But there's online versions, we see that, you know, you can actually use a computer to look at, see what's happening, print out
Yeah.
sections of it.
I was trying to find one and I couldn't find one like that.
I know that Navy sells them for they're like $25 or something for the whole chart.
The Navy.
Yeah, it's the naval, nuclear naval.
Nuclear naval.
Something like that.
Yeah.
Okay.
All right.
Well,
What do you teach?
thank you for.
Chemistry.
Okay.
Yeah. We don't do a long unit on it, but it's nice to do.
Well, yeah, I've always had this argument in the physics community, so some people don't do much nuclear stuff in it, you know.
In physics, right?
And
They don't get to.
it's like, even with the
It
AP.
fits better actually in chemistry in high school, I think. It just fits the curriculum. Well, because you
Yeah, we
could,
talk about energy, but, you know.
yeah, it's true.
Energy is
It's
like,
true,
you know,
but
I
don't
just, I've always put so much nuclear about how, to me, it's more important for a kid in high school, I think, to understand like what a dirty bomb would be if there was something happening,
right,
than to be able to solve Maxwell's equations of electricity and magnetism.
right.
I'm sorry, just, I think it's like,
Yeah.
you know, this is,
I don't know, it
Kids are
fits
gonna be-
really nicely in chemistry because you're talking about, basic atomic structure and the nucleus.
well,
You might
think
as
about,
well talk
that's
a
why,
little bit
that's
about
why,
the forces
that's
and-
why you need to teach physics before chemistry, so you can introduce it in physics into
Right.
nuclear forces and all that kind of stuff, and you guys can take it to the next step in the chemistry part of it, but,
Alrighty, well, thank you very much.
okay.
It's a shame no
Yeah.
one's here, it's like,
Oh.
it's crazy around.
Anyone with
Oh,
this?
thanks. Did you give this out there?
You forgot about it?
Yeah.
You forgot to give these out?
Well, we have some,
We had a few extras.
I have some extra from the, now that I realized.
Alright, what's that, is this different from when you just gave me? Yeah?
No.
It's just a neat video, yeah.
Cool, okay. Thanks.
Oh, here, got another present for you. We forgot.
It helps to stick around.
Well, it does. I really should have put them
Put 'em out?
Actually, this is good because I don't have it, there are already
Okay.
5 left.
I'll give it to Carol, she'll be excited. Alright, thanks a lot.
But at least, one t-shirt and one this. Remember when we gave this away to them? So,
All right, here's your certificate.
that's good enough. So we have stuff now for another one.
That was good.
That's the end of it. Oh, no, yeah.
Yeah, the chemistry people want
They're
us,
not supposed to give us the feedback form or?
No, they're not
They don't do that anymore.
I have to fill it out as needed.
I mean, I think because nobody's probably taking any.
I have to fill a thing out as the chairperson. I have the form here.
Oh, so you got the chairperson. Okay, so they do look at that.
There's a little form, yeah,
And that's it. Okay, Joe.
I think now I have the next one, with Eva and Steve at 1:30. The results of the LHC should be good.
How was the one in the morning?
It was good, it was only about 10 people there, but
Steve is coming to this one.
Steve and Eva will be here for you. I think Steve and I are doing one on top of crazy at 3:30. There'll be nobody here for that, I'm sure. The place will be a ghost town by 3:30. You can shut your camera off.
Yes.